Yes, I currently am paid by Craigslist. They call me artist in residence. That's really short for BS, artist in residence. But as some of you may know, my ancestors came from Northern Europe. They were known as Mennonites or Anabaptists. They first came from Flanders, and then they moved right around here, well, close to here. And they didn't call it, they called it Prussia at the time. So I've always wanted to visit back here to see where we lived back then. After we lived here in Prussia, we moved to Ukraine. Only we called that South Russia at the time because that's what Catherine the Great wanted to call it, I guess. She wasn't the last one to think of the Ukraine as South Russia. Funny how history comes around in circles. Anyway, after Catherine, we moved to Canada, which we actually called Canada. Wonder of wonders. Then we moved to the US, which we thought was called the United States, but now is apparently called Trumpville, USA. Anyway, it's been 200 or so years since my ancestors lived around here, but true to my roots, I still love sausage. My wife, Gloria, says it's probably genetic. I love sausage enough that maybe it's even a little bit religious. So if this talk is about religion, that means it's time to talk about that end of the world there. Repent! Rome is falling. The Huns and the Visigoths are coming. Oh wait, we are the Huns and the Visigoths. Imminent death of Usenet predicted. That's so 1980s. That's probably before most of you were even born. So how about imminent death of Facebook predicted? The singularity is near. Well, actually, I think I'm not going to, it's probably not going to be the singularity. It's probably going to be the plurality. I think the robots and the AIs will probably turn out to be more postmodern than we are. But that's okay. The Perl slogan is there's more than one way to do it. Maybe we'll convince all the robots to believe in that too. Now, one of the very important lessons I learned over the years is that most people really only understand technology from their own perspective, not from some global perspective. If you've been studying a new computer language for 3 weeks, then to you, that language is 3 weeks old. We get this all the time on the Perl 6 IRC channel. Oh wow, that's cool. I wasn't expecting that feature to work exactly like I expected, but it did. Us old-timers like to point out, yeah, we've only been designing Perl 6 for, what, about 15 years now. We'd like to think we got a few things right. But don't pay attention to us old-timers. Well, except me today. You're probably new to Perl 6. Some of you are probably younger than Perl 6. Even if you're an old-timer yourself, just think of Perl as a few months old. Forget everything you know or think you know about Perl. Just think of Perl 6 as an emerging new language. A fairly big emerging language. We don't just include the batteries, we include the battery chargers, the electric grid, and several kinds of power plant. So, okay, yeah, it's a real big language, though it's not nearly as big as English. That's okay, because one of the design principles of Perl has always been that you don't need to know the whole language to start using it. Like a natural language, you can just learn the parts you need now. We also allow people to come to Perl from other languages and to speak Perl with an accent. So we think dialects are okay. In fact, many of the strengths of Perl over the years are based in linguistics. The fact that languages evolve over time, natural languages have no arbitrary limits, there are multiple paradigms supported in every human language. We allow for external influences on design, operator-rich languages more readable, visual distinctions are important, languages are fractal, especially natural languages, in how they relate to each other. Easy things should be easy, hard things should be possible. That's just how natural languages work. And finally, we believe that the language ought to continue growing with you. You ought to be able to speak in grown-up when you need to do that. On the other hand, many of the design flaws of early Perl resulted from me being more of a linguist than a computer scientist. You might say I had a better grip of metaphor than of metadata. Yeah, sure, by the time we got to Perl 5, we had a lot of useful stuff in it, and it fit into people's brains somehow, and it was lucky to be in the right place at the right time for people to bootstrap much of the World Wide Web, but it also had a significant number of design flaws. Perl 6 was nice, but not nice enough. At least that's what we thought in the year 2000 when we got Perl 6 started. In 2000, we announced that there would be a community rewrite of the language and of the community. As to what that actually means, well, it took us 15 years to figure it out. At first, we thought we just needed to tweak things, so I asked for some suggestions. Let me show you just their titles here. Okay, there's 20 suggestions. Yeah, I expected 20. I got a little more than 20. 40. Let's go a little faster here. That's a lot more than 20. A lot more than 20. We got 361 suggestions. I love this one. New Perl mascot. That's why we have a butterfly now. Okay. Long story short, people were hurting in lots of different ways, and while there were many ideas for how to fix individual problems, the set of proposed solutions taken together were just a complete mess. So we ignored the solutions that they proposed and just concentrated on understanding what the pain points were. So I started going through and analyzing each of these things and classifying them into green, cyan, yellow, red, magenta, which conveniently is the same letters as good idea, cultural, yeah, but, rejected, modules, etc. And as we went through and started classifying things into good ideas, bad ideas, but or this is something that people are hurting, but we have to do something different, we started getting a hold of a few of the design principles that we would use with Perl 6. So for instance, we understood that we didn't understand threading yet. And we had to wait until somebody who did understand how to do scalable threading came along, and we did. Pick the right default. Think ahead. Don't plan to confuse things without a really good reason. There's not enough sigils to classify everything. Don't reinvent object orientation poorly. People really get attached to their preferred method of sloppy thinking. Hang things on the right peg. So, I'm not going to go through all those. That would be several other talks. But some of the most important design principles, we had about 60 of them. A few of the important ones. First of all, there is no most important principle except this one. Torment the implementer on behalf of the user. And this is interesting because we attract people who are willing who think it's fun to be tormented in order that the user have a good user experience. We think it's a bug if an error message is less than awesome. Every DWIM, do what I mean, comes with a corresponding WAT, and if so, hide the WAT. Encapsulate cleverness, and then reuse the heck out of it. So, for instance, in Perl 5, there were lots of little clevernesses all over the language. In Perl 5, I should say. In Perl 6, we put those in just a few places. There's a smart matching table where every type figures out how it does pattern matching its own way. There's the precedence table. Once you learn that, everything just suddenly becomes magically cool. There are many metaphors. A class is just a funny kind of a package, but call it a class, don't call it a package. Perl 5 made the opposite mistake. Everything was called a package, even if it was a class or a module or what have you. In Perl 6, we use different words for each of those concepts, but they are really all packages underneath. given the user enough rope to shoot themselves in the foot. Every feature should have high leverage, but not too high. Pick the right defaults this time. Have good examples of all of these. As you can see, Perl 6 is sort of a grand narrative composed of many small narratives. It simultaneously rejects the postmodern syntax polyglot of early Perl, while attempting to do the same sort of postmodern accumulation of modern computer language features down at the semantic level. It's funny, as soon as you start talking about postmodernism, you become completely ununderstandable. But anyway, we have a plan. Oh wait, we have lots of plans. The art of design, of course, is to decide which of these principles applies in any particular situation. Every decision comes with trade-offs, but some decisions trade off more than other decisions. I'd like to mention a few of the more important principles here. When we think of flooding algorithms, we're talking about the freedom to perform multiple experiments in parallel and the freedom for some of those experiments to fail. This is a difficult balancing act. We're an open source project, so most people will only work on what they are interested in. We feature that by declaring that we optimize for fun. On the flip side, we don't tell people what to work on much. We expect people to use their initiative, but usually when people use their initiative, they end up with something not quite optimal. As Theodore Sturgeon would say, 90% of everything is crud. So we need some other sub-principles when that happens, like forgiveness is greater than permission. So while we encourage you to try things, we also encourage you to not get your ego too involved with your experiments. If software experiments never fail, you can never converge on a solution. So let 1,000 flowers bloom, but also recognize that evolution can't happen unless some of those flowers die young. Backtracking can be painful, but no refactor can happen without realizing you've gone down a blind alley. In particular, I would like to honor the Pugs, Parrot, and Nietzsche projects, which were among our most important failures. We learned a great deal from each of these efforts, and we would not be where we are today without them. So, where are we today? We finally converged. In December of 2015, we released the first stable version of Perl 6 as a language, and we're still using that. So, that current version is called 6.c, which is short for 6.Christmas. And what does that contain? Well, we have a fun, handy, scalable, learnable, expressive, optimizable, maintainable, interoperable. They just keep getting longer, don't they? Multi-paradigm, gradually typed, Unicode friendly, concurrency aware, test suite specified, functionally reactive, parametric generic, linguistically malleable, multiple virtual machine, meta-object protocol defined, representationally polymorphic thingy. Technical term, I guess. But in fixing all of these various problems, we decided that these were the underlying issues that we needed to address. And we also saw a lot of other languages doing good things and bad things. So we stole we stole lazy lists and pattern matching from Haskell. From Smalltalk and et cetera, we borrowed lots of different ideas about how object-oriented systems should work and meta-object protocols. From Go, we stole promises and channels to do concurrency. C# and Erlang, the reactive functional programming models. APL, the notion of meta-operators, which modify other operators. But it's easy to slip into marketing mode here because APL wasn't readable. So Perl 6 is APL but readable. It's C# without Microsoft, and Racket without the parens, Python without the global interpreter lock. It's Haskell without the PhD. All right, to summarize, I finally got you to laugh. Okay. In short, to generalize that, your favorite language sucks at something, and we intend to fix that. And so Perl 6, it's the last programming language you'll ever want to use. Now, you can take that either way. We're not picky. But seriously, while we worry a little bit about whether our language is learnable, we worry a lot more about whether it's the sort of language you could happily use for the rest of your life. We want Perl 6 to be the sort of language that gets more powerful as you get smarter. Most computer languages make the opposite mistake. We want to make different mistakes. But I think you'd rather just see some code to show that Perl 6 actually works and looks pretty decent. One place with lots of good code examples is rosettacode.org. I'm not going to, it's down here somewhere. It was down here somewhere. There it is. So if you go out there and look, you find that Perl 6 solves all of these 937 different problems. So you can pick any one of them and see how Perl does it, and how Perl 6 does it, and how that compares to other languages. You know, one of those tasks is called forest fire, and I'd like to kind of show that to you here. The resolution here is, let me dump down the resolution a bit. It's like almost too hard to see it when it's. This is a crude simulation of a forest ecosystem and wildfires. We start with about 50% coverage of virgin forest. Fire burns up most of that, and then eventually we settle down to a quasi-steady state. Now, there are two different forms of propagation here. Trees propagate slowly while fire propagates quickly. If I can draw a metaphor from this, many modern computer languages are like the fire. They do one or two things really well that no other language has done before and suddenly become popular. But then they tend to run out of fuel quickly. Sometimes I feel like we should invent a flavor of the month club for computer languages, and maybe web frameworks and container technology. Perl 6 is not trying to be the flavor of the month. It's trying to do the opposite. It's trying to propagate more like the forest, slowly but inexorably. We don't really care if one of the flavor of the month languages eats up a little bit of our forest. Wildfires are just part of our ecosystem, and maybe they even help our seeds germinate. Anyway, enough of that. Show me the code. Okay, now I'll have to blow it back up again. Can you read that? First of all, notice that Perl 6 is highly declarative, even more so than Perl 5. All these things in red here, constant, my, has, class, has, method, and so on. These are what we call declarators that introduce a declaration at compile time. We also have declarative modifiers, we call them traits, like this is required here. Anyway, the is required here is an annotation that modifies the has declaration. And notice that unlike other languages, these sort of annotations are put after the main declaration. You don't put all this hash of words out in front, static, virtual, blah, blah, whatever. And finally, at the end of the line, you get the actual name of the class or the method. Instead, we hide the less important things off to the right. Off to the right. You're that way, right? Okay. Below that, you'll see some other declarations that can take default values. Here, the parameters, the probabilities of a tree growing or catching fire randomly. So, yeah, Perl 6 is highly declarative, but when we say declarative, we mean something a little different than usual. For most computer languages, if you call something declarative, it's fixed in stone. It's built-in syntax, and you aren't allowed to change it. Our language is already perfect, so why would you want to change it? We call this the one true language syndrome. Perl does not suffer from this. You can add declarations and change the language within any given lexical scope. The compiler itself is written in Perl 6, so you don't have to learn a different language to, say, add your own declarations of traits. And that's perfectly fine with us. You're allowed to mutate Perl 6 into the language you really want right now. For example, we have modules already that implement things like monitors or actors as user-defined declarations. Turn class to an actor class. It's really pretty trivial, about this many lines. So, I mean, yeah, it's right now. It's not a built-in, but that doesn't really matter. It really doesn't matter because, in a sense, almost everything in Perl 6 is out in the library. Most of the declarations you think that are built in are actually written in Perl 6. Sometimes languages talk about a prelude. Haskell uses that term. We prefer to call it a setting because it's wrapped around. With Perl 6, those definitions are not conceptually out in front, but rather they're wrapped around your program as an invisible outer lexical scope. So the setting isn't special, it's just outside. If you override something from the setting, you're doing so by the same mechanism that you override the definitions of any outer lexical scope. So tweaking inner scopes is how you redefine the language. So our standard setting definitions are defined in exactly the same way as user definitions are. So take, for instance, this X operator here. Okay. In many languages, the set of operators is fixed, and maybe even the set of behaviors for those operators is fixed. Because our setting is just an outer lexical scope, you can override or add to the behavior of the X operator in your own program. Now, we can look at the original definition of it. Oh, wait, you probably want to know what X actually does, don't you? It's just the Cartesian cross product. If I run that, it just matches up everything with everything else. But I mentioned that we borrowed the idea of meta operators. So this can also function as a meta operator. Instead of just concatenating lists together here, we can use that X to modify the concatenation operator. And in that case, it's a cross with, and we concatenate every combination of letters and strings. And that can be used for any other infix operator that's built in. So we were going to look at the definition of the X operator here. The first thing to notice is that the operators are really just functions with funny names. Well, and because of those funny names, the parser knows where to look for them. It won't look for an infix where a term is expected, for instance. And this is extensible depending on your grammar, so you can make as many different of these namespaces that you like. The namespace is actually defined up above. There's an infix namespace, and everything that's in that infix namespace can be used where an infix is expected. And these are really just methods in a grammar here. So when it calls out to these, your class could define its own infix x's here, which would just get mixed in with these, and it would just call the right one depending on the arguments, because it uses multi-method dispatch. Now in this case, there's two forms of it built in. One of them just takes a list, and that is the standard X operator, bare X, that you saw. This one takes a function to cross-iterate it with, and that is the higher order programming, the way we did the cross-concatenation. We just passed in the concatenation operator as an argument to that, and it applied that. Now, this is all kind of like highfalutin functional programming internally, but notice how simple it looks in our actual program. It's just a nice standalone operator there. It stands out visually. We make it uppercase so it sort of dominates the lists on either side. So what I'd really like to convince you down deep is that Perl 6 is really both fundamentally a functional programming language as well as an object-oriented programming language. And really what I'd like to think is that we can make pretty much any programming style more readable than many of the languages that purport to specialize in that style. We do imperative programming prettier than C, we do functional programming prettier than Lisp, we do object programming prettier than Java. Well, maybe that one isn't hard. So if you go down here and this is the class that represents the forest. It has various methods in it. And one of the methods is like the show method that shows the page of the thing there. And so this for here, this for loop might look imperative to you. And if you want to think of it as an imperative construct, that's fine. But it's really just a functional map underneath. And I can show that. I can just say, take this value, run a map on it. Now, notice I didn't change anything here. This is the lambda form in Perl 6. It uses the arrow and has arguments there. And if I just change it to that, it should still work just fine. So map is a very functional programming concept. And yeah, it's doing I/O, which is a side effect. And yeah, our lists are lazy, but the syn context there kind of behaves a little bit like an I/O monad, if you're into that sort of thing. And it pulls the values out of the lazy list, which triggers the side effects. But it goes deeper than that. Each of these methods is really just a function underneath. The only difference is that a normal function is stored in your lexical scope and uses the function dispatcher. A method is stored in the metaclass object and uses a method dispatcher. They are implemented exactly the same underneath. On the surface level, most of the time, functions are entirely distinct from methods, and we work really hard to keep the naive user from confusing them. But down underneath, everything is unified, and you can install functions as methods, or call methods as functions if you work at it. So when it comes to mixing paradigms, we always try to have our cake and eat it too. Not by forcing novices to convert from one paradigm's religion to another, but by maintaining deep unifications under the surface differences so that we can be both novice and expert friendly. Easy things should be easy, and hard things should be possible. You may have heard that phrase before. So Perl 6 is not just the first language to claim multi-paradigm support, but that's just one of the areas where Perl 6 is trying to raise the bar. Now let's see, where did I put my Christmas tree? There it is. How about, say, let's talk about Unicode support. We saw a little bit of that in the Forest Fire program where we used the tree character from Chinese. But what if we want to use a character from outside the basic plane? Does your language handle emoticons as single characters? Does it split them into two? Does it handle emoticons with face colors as a single character? Can you just paste any old character into your program, or a new character in this case? Could we replace the tree in our program with one outside the basic plane? Let's try it. Here's the Chinese character for tree. Let's look up various tree characters in Unicode. What shall we use? Well, obviously we need to use a Christmas tree. Okay, there's a Christmas tree. Okay, now we're burning up all our Christmas trees. So, we do Unicode. But Unicode is not just for the insides of strings. It's also for the outsides of strings, right there as part of your program. Perl 6 programs are natively Unicode-y. On a deep level, you can always define the appropriate Unicode operator for what you're doing. And so you don't have to overload operators. You won't be tempted to overload an existing operator for an unrelated function. Other languages do this, and it drives me nuts. I'm looking at you, C++. Greater than is I/O? No. But on a shallower level, handling Unicode saves many irritations. How many of you have tried to program on a smartphone or tablet? And how many of those clients do smart quotes? Does your favorite programming language accept smart quotes? Okay. I mean, here's a sequence that goes from A to double Z, and I can run that, and it produces that. But you type that into your smartphone, if it's an American smartphone, it might do this to it. Oh, gee, it still works. Well, what if you're in Poland? And you write your quotes like this, your smartphone writes your quotes like this, and you don't notice. Well, that still works. What if you're in Hungary and write the other quotes backwards? Oh, that still works too. What if your phone changes ... into ... That still works. Now your phone probably doesn't do this, but what if your client somehow turns less than or equal into the Unicode less than or equal? That still works. Both those are true. And we call this NFG, NFC on steroids. We'll talk about what that is. But suppose you had this perfectly ordinary string encoded this way. It's just ASCII, so the number of characters in it, nobody disagrees. It's 6 characters, it's 6 code points, it's, whoops. Help if I hit the right key. And those things agree. But what about if you're a mathematician and you want to write a vector with a mu and a little arrow on top of it? Now, how many characters is that? Well, you probably think of it as 1 character if you're a mathematician, but in Unicode, that's 2 code points. That could be a problem, couldn't it? What if we reverse it? Is it going to put the arrow in a different place? In Perl 5, we originally had ASCII. So it thinks there are 49 characters in that little string there. Does it look like 45 characters to you? Well, it's 45 bytes in UTF-8. So we have to say, oh, it's UTF-8. Now everything's fine, right? Well, not exactly. It still thinks there's 27 characters in it because there are 27 code points in that. A lot of combining characters on those 5 letters. Well, what does Perl 6 think? It thinks there are 5 characters. Now wait, what's that NFG thing we're talking about? No, it's not the American phrase that is, well, any resemblance to that is purely intentional, but okay. Anyway, here's how it works. Imagine in a distant future in which NFC is extended to have pre-composed characters for all the normal purposes in every human language, for every emoticon in every color, for every possible flag of the world, for anything else that the Unicode Consortium dreams up next year or the year after. NFG, normalization form grapheme, we call it, is attempting to emulate that future. If there's already a pre-composed NFC grapheme in Unicode, then we can just use that. But if there isn't a pre-composed form, we pretend there is one. We create a temporary pre-composed grapheme so that it can pretend your composed form is a single character. This temporary grapheme, a negative number actually, exists only within the program. Since it's meaningful to other programs, we translate that negative code point back out when we do the output. But before that, we can store the negative code point in a single integer internally. And that means when you index it to a string by grapheme, it's very efficient. For example, doing a subster here, because it never has to actually skip over variable width encodings. It's just a linear array of graphemes. So more importantly, it simply does what the naive user expects. So the naive user says, there's 5 characters there, just give me the third and fourth ones of them. And that's what it does. Or if you reverse a string, the combining characters all go with their corresponding letter. It doesn't move them to different ones. A lot of other languages screw this up completely because they only work on a code point level. Now, Perl has always been Unicode friendly, and Perl 6 is even more so. We're arguably insane on the subject. Suppose you live near Mount Everest and want to write your numbers in Tibetan. No computer language is going to support that, right? Well, now you notice that we don't support Tibetan on output. We may be insane, but we're not crazy. Or suppose you want to write in cuneiform. Anybody know what that is? Should be obvious. There's 9 marks, so that's number 9. Or suppose you want something more in line with Indo-European sensitivities. I mean, we have vulgar fractions. It all follows out of the simple Unicode properties, though. These all have a numeric value in Unicode, and Perl knows that, so it just says, okay, we'll just throw that numeric value in there if you want it. So everything really is an object in Perl 6, so we can ask 3/5 what sort of an object it is. It says, I'm a rat. Okay, and we can ask it, well, okay, if you are a rat, what kind of methods do you have? Those are our methods. This is all the methods for the rat class as well as its parent classes. And you might wonder what this nude method right here is. That's actually just the method that prints out the numerator and denominator, but you will not forget that method name, I can assure you. There's probably a joke in there about the objectification of nude rats. Maybe they're naked mole rats. So what else? Well, we can ask for the Perl representation of a number, and in this case, that is how it represents a rational number. Most languages fail this test. If you add 0.1 and 0.2, does it equal 0.3? Try it in your favorite language. It probably will not be equal. In Perl 6 it is, because these are parsed as rational numbers. That's 1/10, 2/10, 3/10. And at that level, it is exact arithmetic. If you add 0.1 each time, does it ever exactly match 10 at the end? In many languages, it would just run on forever because it would be 10 and some small change. In rational arithmetic, it matches exactly. It does what you want if you're a naive user. Here's our more examples of our sequence operator here. I can say, well, you know, if I want to print 1, 2, 3, ... 10, what does that do? Well, 1 through 10. Or we can just say print 1 through whatever. Will it do that? No, it says, that looks like infinity to me. I'm not going to do that. I'm going to be lazy. That's just saying, I'm being lazy. Well, what can we do? Well, we could subscript that infinite list and say elements 0 to 39. But usually, when you do that, what you really mean is everything up to 40. So 0 to 40 minus 1, right? That's how you'd have to write it in Perl 5. But we have a shortcut for that. If on the range you put a little caret on the end that says exclude the endpoint. So you can do 0 to 39. But that's still too much writing. So we have a unary operator that just says up to 40. And that's all the integers from 0 through 39. It does the same thing. So you see that idiom all the time. You saw it some in the forest fire thing already. But we don't always have to add 1, of course. How about even and odd sequences? Add 2 each time. There we have our 2 sequences. And we're not limited to even adding. What about geometric sequences where we multiply instead of adding? 1, 2, 4. What comes after that? 8, obviously. 16, 32. And sometimes you don't even see, you know, things as a geometric. Is this a geometric sequence? Sure, it's just multiplying by -1 each time. It goes on forever. It's never going to get to infinity, but that's okay. We can still take the first 40 elements of it. And yes, you see, if you happen to use infinity instead of INF or whatever, this still works. This works, up to 2 to the 32. Does what you expect. Well, of course, if you really have OCD, this is not consistent enough. You have to write it like this, right? That still works. What if you write this? It's obviously maybe the start of the Fibonacci sequence. No, we're not going to do that for you. We actually thought about baking in all of the online dictionary of integer sequences and decided not to. That would be crazy. However, if you give a sequence of numbers and then a function that is the iterator function that says what to do with the previous numbers, then you can do it. So you can just pass the name of the built-in plus operator, or you can pass a lambda that does it, or here's a shortcut with place-hurl arguments that also does a lambda. This also is a very fast way of producing a lambda using whatevers from inside out. So we say 0, 1, whatever plus whatever, up to 987. And these all produce the Fibonacci sequence. Well, okay. Is it really calculating in an infinite sequence? No, of course not. If we take the elapsed time, we see that it only takes a few thousandths of a second there. So, more fun with functional programming. We started a little late, didn't we? But I need to wrap it up here pretty quick, don't I? Okay, well, you can do function composition, so we can compose a log and an absolute value together here and get a real number instead of not a number out of it. Fold operators. If you say 1 plus 2 plus 3 plus 4, you could also do that as a reduction with the built-in dot reduce method here, but that's still too long. You write it with lambda. You can write it with the short inside-out form, the whatever form. That still works, whatever. But usually you just write a reduction like this. You take whatever infix operator you want and put it in square brackets in front, and it becomes an operator that reduces over the following list. That still works. And you can get the intermediate results. So 1, 3, 6, 10, like bowling pins, you know. So, oops. And you can also get the intermediate results of an infinite series, as long as you don't evaluate the whole thing. 1, 3, 6, 10, 15. So all your good triangular numbers there. And if you like to play Yahtzee, you roll 5 dice, and you can use any infix operator, including things like least common multiple, to analyze a list of numbers. And you may ask, if you're familiar with functional programming, well, is that left fold or is that right fold? Answer is, it's whatever it's supposed to be. So for multiplication, that is left associated. It goes left to right. For exponentiation, it goes right to left automatically. And both those are true. Here's a fun one. If you add a bunch of numbers like this, sum them up, you get the right sum. But if you sum one number, well, you just get the number itself, right? What if you sum 0 numbers? Well, obviously, that's, whoops. Obviously, that's the one I just did. Sum 0 numbers is obviously 0. What if you multiply 100 numbers? Well, obviously, we have arbitrary precision integers here, but more to the point, if you multiply one number, what does that mean? Well, you still get itself back. What if you multiply 0 numbers It's not 0. It's 1. Because that's the identity element for multiplication. It knows the identity elements of every operation. So, for instance, you can do cascaded comparisons here, and these are respectively true and false. If you write them as reductions, it still does the right thing. Those are true and false. What if you have no arguments to that? I mean, you can't write a Baronier operator with no arguments, but you can write it like this. Well, it's true, because it's true until proven false. What about min and max? Those are infix operators in Perl 6 so that you can do reductions like this and get min and max over a sequence of sequence of things. But if you have a min and max in the list, the two identity values, or the two starting values, are infinity and minus infinity. What about GCD, greatest common denominator? It's like, no, that doesn't mean anything. Okay. Other meta-ops, I'm going to wrap this up pretty soon, but you can reverse things. So I'm going to define a thing that puts bow ties and call it beta, and I can have a reverse bow tie here that does, notice it puts the 43 first. I can zip them together, two lists, so I'll get A and B zipped with 1 and 2. Remember the X we had before, that does the cross product of all of them. And notice we're doing this with an operator that we defined. You can do any of these meta operators, not just on the built-ins, but any operator that exists at that point. Everything is structured such that you always know the current language and everything that's in it. So you can always just process the current language. You can stack them up so you have an X reverse, reverse X reverse, which actually gets us back to the original, I think. Yeah. Anyway, there's lots of other stuff that we can talk about. Hyperoperators for parallelism, promises and channels we mentioned, reactive programming, representational polymorphism is how even the classes in Perl 6 don't know what the representation is. It might be a Python dictionary. It doesn't care. You just write the class the same way. So that's how we can have interfaces to Python and other languages, Lua, and we just use whatever they give us as an object and just use it directly, as long as we have a representation defined for that. Stuff out of C++, no problem, native types. Metaprogramming, don't have time. Have 3 backends right now, including JavaScript backend, which is by Paweł Mariusz. He's Polish. Yay. Various inlines, great native call facility. What's the future? Well, part of the beginning of Perl 6 was Paul Graham writing this article on what he called the 100-year language, and he speculated on what it would take for a language to last 100 years, and we kind of took that to heart and said, well, what we need to do, we need to make a language that's evolvable over time, because we don't know what language we're going to want in 20 years. We need to encourage wide gene pools so that the language is ready to adapt into a new ecological niche when it shows up. Limit mutations so they don't take out a large part of your population and hang things on the right peg. And just basically put things in the right namespaces and figure out how to tweak languages such that it's under control all the time. Don't have time to talk about all that, but it's all about identity, and you always know what language you're parsing. But anyway, I should probably wrap up here since we're out of time, but it all works. Okay. I think we have another talk starting in here. So let's take questions outside.